I've got plenty of problems to go through, so I just as soon jump right into the work for today. This is a problem that we left off on last time. A solar cover made for a pool is to rest on top of the pool and include this wedge-shaped opportunity to get into the pool. Okay, it's wedge-shaped, forms a 30-degree angle at the center. And it's shown in this figure here. All right, so the zipper is sewn along one side of the wedge and around the arc right here, and I tried to acknowledge that right there. All right, so that's where it's sewn. Okay, then it says that which of the following is closest to the length of this zipper here. So they want to know what this length is, and don't forget, this unit was in ratios and proportions. All right. So what I told you when dealing with ratios and proportions is I told you to acknowledge. The ratio. Acknowledge the ratio. I emphasize that we're to label. Emphasize that we're to label, and then I emphasize that we're to cross multiply to solve. So these are the steps that I emphasized to do these problems. Now, last time I had some serious issues, and I really, really apologize. All right, but what happened last time was I didn't have all the information. All right, so the information that I didn't have last time was that the diameter was 20. All right, so if the diameter is 20, that means that if from here to here is 20, that means this radius has to be 10. And if that radius is 10, you're able to get this arc length here using the ratios and proportions that we've talked about previously. All right, so what you have to know here is that the ratio that's given was going to come from your understanding of geometry. All right, so you understand geometry, you understand that the distance all the way around this circle is 2 times pi times the radius, which is 10. That's the distance all the way around, and that would be in inches. I'm emphasizing labeling. So 2 pi times the radius, inches, and then the degree measure all the way around is 360 degrees. So that's the ratio. This is the first time, really, our ratios come from a geometric principle. So let's just label that degrees. All right, degrees. Then you want to know what this length is. So what's unknown is this length in inches. So let's put the unknown inches up top here, x inches. Now, if we had not labeled that inches, you wouldn't have known to make that inches. So that's why we've emphasized the importance of labeling. Now, the degree measure here is 30. If that's 30 and that's a central angle, that has to be 30 degrees. All right, so now you set up your proportion. You got your ratios, you label, you set up your proportion, now cross multiply. This is 20 pi, 10 times 2 is 20. You get 20 pi over 360 is equal to x over 30. All right, so now you cross multiply. You get 60 pi, or excuse me, 600 pi. Sorry about that. 600 pi. 600 pi is equal to 360 times x. You're going to divide by 360 on both sides. Divide by 360 on both sides. The zeros here cancel. Each of these are divisible by 6. Each of these are divisible by 12. So you get 5 pi over 3. So x is equal to 5 pi over 3. So that is in inches. So this length here is 5 pi over 3 inches. So this total length of the zipper, we found this length, we found this using ratios and proportions, we found this length just using basic an understanding of a radius is half the diameter. So now to find this overall length of a zipper, you'd add the zipper length is equal to 10 plus 5 pi over 3. This is like an ACT type problem. And on the ACT, you're allowed to use a calculator. So let's use 10 plus, and then let's take the 5 times the pi, divide 3, and you get 15.2. You get 15.2, which is very, very close to D, final answer. So that's an ACT type kind of problem that we want you to be able to do. But it's rooted in ratios and proportions.